Hello students, today in this video let us continue with module 2 corrosion and metal finishing. In the previous video we were discussing about corrosion control methods. Three main important corrosion control methods you need to study according to your syllabus. First was anodizing of aluminium, which we understood in the previous video, where we made the article to be protected from corrosion was made as anode, and the outer surface of the metal to be protected was converted into its oxide. Particularly in the anodizing of aluminium, the outer surface was made as aluminium oxide, and hence it was protected from further corrosion. Now in this video let us move on to one more method, which is cathodic protection. Here name itself indicates the article to be protected from corrosion is made as cathode and hence protected. So we already know that during corrosion on the surface of the metal there will be formation of anodic areas and cathodic areas. At anodic area the corrosion initiates and it spreads across the anodic, as well as it covers the entire even cathodic area in the case of severe corrosion. So if by any means we can make the article to be protect from corrosion as cathode, so there will not be question of corrosion. So let us understand this method. What is cathodic protection? Cathodic protection is a technique used to control the corrosion of a metal surface by making it the cathode of an electrochemical cell. Okay, if you want a particular exact definition, so it is a method of protecting a metal against corrosion by making the entire metal cathodic by supplying electrons from external source. Now here how it made as cathode, the entire throughout the entire article to be protected, which is made as cathode, the external electric supply is method. Anyways, there are two main methods, two types of cathodic protection systems, which are sacrificial anode method and impressed current method, which we'll understand one by one. Sacrificial anode method, as the name itself indicates, sacrificial anode are introduced here, which are connected to the article to be protected, and they undergo corrosion. So let us begin with it. In this method, the metal to be protected, for example Fe, iron, if the metal to be protected is iron, is connected to a more active metal like magnesium or zinc. So now see here, okay, let us first finish this. More active metals like magnesium or zinc. The anodic metal undergoes oxidation and sacrifices itself to provide electrons to the metal to be protected. Now here imagine there is a iron article or iron metal structure which we need to protect from corrosion. So then what we need to do, we need to connect more active metals such as magnesium, zinc to the iron structure, so that those active metals magnesium, zinc undergoes corrosion first. Hence they sacrifices themselves, and hence they protect the iron metal structure. So in this way the anode, whatever we are connecting, is sacrificed or it is lost, and hence the method is known as sacrificial anode method. Once the sacrificial anodes are completely corroded, they should be replaced with fresh anodes. So now here to protect, it doesn't make sense to protect one structure, we are losing one more structure. Now here, so this method is specifically applied to such structures, huge structures. For example, if we have a huge metal ship, So we don't want to lose that metal shift. For that, we can adjust with some other magnesium or zinc wires or slabs, so like that. So magnesium or zinc slabs are connected to that large metal structure, and hence that large metal structure is protected. So let us observe some diagrams or some pictures. As you can see here, so this is a iron pipeline. So pipelines will be huge pipelines, large, till kilometers they will be. So how to protect them? So for these iron pipelines, so magnesium slabs are connected. So what happens here? Magnesium, this part acts as anode and this becomes cathode. Why? Because when we are comparing activity of magnesium and Fe, magnesium is more active as compared to iron. So now how exactly corrosion, what are the exact corrosion reaction? We already know. At anode, oxidation takes place where magnesium undergoes oxidation, forming magnesium ions and liberates electron, on the cathode there will be reduction reactions where there will be formation of reduction products. Then those reduced products migrate towards the anode and corrosion product performs on the anode itself. In this manner, this cathode is protected from further corrosion. One more example here. See, iron pipeline is buried underground. So how it can be protected? Because in the soil also there will be lesser oxygen concentration. So because of which there will be corrosion occurring. To minimize that, see, sacrificial anodes, any other active metal, then this iron pipe is connected to the iron pipe, and it undergoes corrosion, and hence this iron pipe is protected. Okay, so one more example here. See, in this, here is a picture where as you can see underwater water structure it is. Here as you can see there is a concrete structure which is mainly supported by these iron pillars. If by any means imagine these iron pillars undergo corrosion, then the entire balance will go off, and this structure simply destructs. So if that happens, as you can see, if like this corrosion happens to these iron pillars, then the entire structure destructs, or destruction of the entire structure may occur. So there will be huge loss. To avoid that, what we can do, as you can see in this picture, once again, the underground, what we can do, this is iron pillar, and one more active metal, it could be magnesium, zinc, any metal is connected to this iron pillar. So it acts as anode, and it will undergo corrosion first, hence it protects the iron pillar. In this way, sacrificial anode method works. So let us see some of the advantages and disadvantages of this method. Sacrificial anodes are used to protect the hulls of ships, water heaters, pipelines, distribution system, above ground tanks, underground tanks, and refineries, etc. Now, what are the advantages? Method is simple and economic. No power supply is required. Minimum maintenance cost. Okay. So, now what are the disadvantages? Loss of active metals, the only possible disadvantages of this method. So I hope the sacrificial anode method is clear to you. Let us move on to next method, which is impressed current method. In this method, the metal to be protected is connected to negative terminal cathode of a DC source. Now here name itself indicates impressed current method. In both the methods, sacrificial anode method as well as impressed current method, the article to be protected or structure to be protected is made as cathode. How we are doing that in the previous case, that is sacrificial anode, we are making it as anodic metal by connecting another metal which is anodic to it. So hence it was made as cathode. So in impressed current method, what is done? So here external electricity is supplied through the structure to be protected. In that manner it is made as cathode. So how it is made? To the DC source, the article to be protected is connected to the negative terminal, hence it attains the negative charge, and to the positive terminal, inert anodes like graphites are connected. So here anode is graphite, cathode is our metal to be protected. Here the anode is buried in the soil and connected to the structure to be protected. To avoid any leakage of electric supply, the anode must be insulated first, then it must be buried in the soil. So the DC current is applied to supply electrons to the metal to be protected. So here the current applied in the opposite direction nullifies the corrosion current. Okay, so let us observe an example: oil pipeline protection by impressed current method. So here is a diagram. As you can see here, there is a iron oil pipeline. So there will be DC power supply to the negative terminal of which this oil pipeline cathode is made as cathode, it is connected, and to the positive terminal inert anodes or graphite anodes will be connected. To the calculated in distances, these inert anodes or graphite anodes are placed or connected. In this manner, what happens? So continuously negative charge or electrons is supplied to cathode. So when there is supply of electrons externally, so there will not be any natural reaction. What is that natural reaction? Why exactly this corrosion takes place? We already understood. At anode, the metal undergoes oxidation, formation of metal ion as well as electrons takes place. Those electrons are nothing but negative charge which are in demand. So hence cathode requires those electron. To gain that electron, what happens? In the current, there will be generation of a corrosion current. In this manner, reduction reaction takes place and our corrosion production and all occurs. That's a different thing. So if by any means if we can supply those electron externally, there will not be any case of anode undergoing oxidation, hence there will not be any corrosion. So in the first method, sacrificial anodic method, article is made as cathode by connecting more active metal as anode. So in impressed current method, what is done? The article to be protected from corrosion is made as cathode by connecting to negative terminal of the DC supply, and any inert anodes such as graphites are connected to positive terminal of DC supply and made as anode. In both the cases, the metal structure or article to be protected is made as cathode, hence the method is cathodic protection. So then what are the advantages and disadvantages of this method? Let us see. So impressed current method is used in water tanks, buried pipelines, carrying water or oil condensers and transmission lines and ships, etc. Advantages: requires low installation cost and minimum maintenance cost after installation. Method protects large area of the base metal. Here base metal is nothing but the metal to be protected. And what are the disadvantages? Method is expensive due to requirement of high current, is it? So one more disadvantage: it is difficult to maintain uniform current over entire metal surface. As a result, a localized corrosion may occur. So now we are supplying current through a iron pipeline. Say if there is its surface is uneven and all, there will not be equal distribution of that supplied electricity through it. So there might be localized corrosion. Again, once again, because of the excess supply of current, if moisture and all is present on the surface of the iron pipeline, then it may undergo reduction, and hydrogen gas evolution takes place. And when hydrogen gas evolution takes place, there is once again chances of direct corrosion. So in this manner, these are some disadvantages of this method. So I hope both the methods, impressed current method and sacrificial anodic method, you understood. So thank you, students.